Right, so collusion. Well, we maybe I'll get out of the way. The screen's a bit busy. So we thought about what collusion actually is. Collusion is a form of cooperation between AIs that has some negative effect on humans, right? Cooperation between systems that we don't actually want to cooperate. And it might use something like steganography or cryptography as a communication channel between these agents that are colluding. Yeah, so the goals are to detect and prevent collusion.
Sure. I think we kind of went all over the place with these conversations. One thing that we found useful was to treat games or market designs, I guess, areas where there is meaningful collusion and to kind of zoom out and really talk about how do we combine a bunch of agents into a super agent. So like a market is a super agent made out of a bunch of humans whose job it is to price goods. And if you think about this like toolbox of ways that you can combine agents together to form super agents, what are the properties of the super agent? So if the super agent, you wanted to price goods accurately, but because the way you've combined the agents, they're colluding, then the super agent is actually really bad at pricing goods accurately. And so kind of thinking about the game or the market as itself an algorithm for combining agents together, and then trying to understand why is this super agent failing. One reason it might be failing is your small agents are bad or not really not good at learning, not good at optimizing. But another reason it's failing is your game parameters are ones where collusion emerges. And so if we can find ways to if we're trying to optimize the super agent, then examining the game dynamics may be a useful way to do it. And so I don't know if we want to scroll down, but one thing we talked about is like what sort of mechanisms in the game make collusion easier or harder. So if you give agents a private communication channel, it becomes easy to collude. Whereas if you don't give it to them, maybe they'll still discover it through things like steganography or cryptography, but it's harder. Similarly, if you give agents persistent identity, it becomes easy to collude because they can then have memories of trust. Whereas if you don't give them something like persistent identity, or essentially if you have a game where you have less mechanisms for trust than you get, then collusion becomes harder. And so we're kind of thinking of this as game design parameters that make a certain types of behavior easier or harder, and collusion as one lens through which you can look at your superorganism and decide why your superorganism is not as fit for your problem as you want it to be. I don't know if you want to say anything. I don't think we have like a project direction or anything to try to, or maybe you do.
Not really. But I guess kind of one starting out point might be kind of building on these two things is to kind of survey, taxonomize the different sorts of kind of means via which agents could collude via some kind of communication, via some kind of ability to build in norms or institutions or things like this. Yeah, all these sorts of kind of means, and then kind of basically run some kind of simulations with these, understand which are the kind of mechanisms and means that lead to greater degrees of collusion, given some suitable definition of that, and then kind of try to work out where the kind of relevant pressure points are in terms of which are the more tractable things in terms of preventing those mechanisms from arising in the first place. So yeah, that's kind of like a kind of two-step initial thing that you could do, and then there's some kind of like further thoughts on this here. I guess the point that's being highlighted right now are like downside risks to this sort of work, of which I think there are two potentially obvious ones. So one is that actually being able to disrupt cooperation or producing mechanisms for disrupting cooperation could be bad in situations where we want cooperation, and if we enable malicious actors to do that. And also the ways in which we might detect collusion could involve the development of certain kinds of surveillance tools, etc. Like if we're worried about, for instance, agents communicating in order to collude with each other, then we might want tools where we can very carefully monitor the communications that agents are having with one another, which could be something that could be used badly in some cases. So yeah, some thoughts there. And then maybe, I don't know, Andrew, if you want to comment on some of that stuff.
Yeah, and I guess part of the reason we're sort of doing this, like, framing in terms of, super agents is it's kind of hard to think about collusion on like a really small scale because it's pretty simple to come up with like a 3-player game where you sort of like the obvious Nash equilibrium is for 2 agents to always cooperate with each other at the expense of the 3rd agent getting some like really badly negative rewards. But this isn't really collusion in the sense that a lot of people care about when they think about collusion. It sort of like is sort of indistinguishable from people just following or agents following the optimal strategies and doing things that aren't necessarily bad for some definition of bad. Whereas in like large systems with different game parameters, you can sort of quantify some super agent goal, like David mentioned, where you can use whether the super agent goal is being achieved as somewhat of a metric about whether collusion is happening to an extent that we would want to prevent. And I guess the next steps are sort of like what Lewis mentioned, to sort of make a survey that does this taxonomy of what different games and what like agent parameters lead to collusion, what sort of doesn't lead to collusion, and when do we actually care about this happening.
Okay, wonderful. Questions, comments, helpful remarks?
Cooperation between independent agents is, to me, what you would call society or economy. Don't we mostly want independent smart agents to cooperate with each other?
Yes.
I think it depends. If you think about ways that we combine smart agents to get super smart systems, sometimes those dynamics we want are cooperative dynamics, and sometimes we want adversarial ones. So our justice system is based on an adversarial collaboration between a prosecution and a defense, and part of that, the fact that we set them up adversarially means that communication is public. For example, they can't like go. So there's a bunch of reasons why we might want to take agents and put them together in a non-cooperative way in order to build a super agent that is able to do something better. And yeah, I agree. I think ways in which smart agents interact, there's like many ways we want them to interact, and we want to have a design toolbox that let us craft like a super agent with various like interaction patterns.
I guess like the other classic example is, in the super alignment research agenda, you want to trust that like the red teaming that your alignment researchers are doing is like actual red teaming. They're not colluding in some way to pretend to, be getting good alignment results.
Yeah.
Questions, comments, helpful remarks? I think it would be interesting to also maybe try an approach where perhaps you have like a diversity of different agents with many like different like goals, basically, because that is, I guess, like one thing I think Drexler mentioned in one of the open agency stuff of like collusion may be less likely in situations where you just have like a diversity of different goals, or like at least you could like perhaps like simulate that out, like how that would affect things, like just like how far they have to vary on individual things.
Yeah, so there are various results that are known about if you can introduce agents into an existing system, then they can end up kind of destabilizing kind of existing kind of cooperation things and so on. And you get kind of quite interesting like network effects and so on about when you do this. And that also might be kind of like one means via which you can in fact reduce collusion. If you can inject some kind of other agents into the things to kind of like monitor things, to kind of keep an eye on things, to kind of tip things towards more competitive dynamics here and there where you want them to do that. That could be an actual, like, relatively like scalable and tractable mechanism that relies on a kind of slightly more decentralized approach as opposed to having some overall high-level like mechanism designer system-wide view, which is going to be impractical when it comes to things of any kind of like scale, basically.
Any final comments, questions, concerns? Yeah.
Yeah, I got an idea from what you two just said. What if you have a population of agents and then you introduce some new ones, but at the same time you kill off some of the older ones, like with the memory thing that you mentioned earlier, so that they don't get time to get evil, if you see what I mean.
Yeah, I mean, I would view this as, what sort of dynamics make collusion easier or harder? And if you think that, it takes some time to establish a collusion mechanism, like you have to build trust or you have to agree on, discover Schelling points that you can collaborate around, then having an environment that's non-stationary where things are changing either because the nature of the environment has changed or you've introduced a bunch of agents in there or you've killed off a bunch of agents, like all of those things make it harder. So, and so, yeah, I would see that as a way of making collusion harder by just changing the dynamics of the environment.
Awesome. Thank you, guys.